Quadcopters. What an interesting topic to discuss. In this video, we will explore some basic terminology used to describe the flight of multi-rotor drones, such as quadcopters or any flying machine for that matter. The concepts are not specific to drones, and therefore we will also use examples of other flying machines so that the topic becomes easier to understand. But before we dive into details, let's gain an overall understanding of quadcopters. Technically, a quadcopter is defined as a robot. It's a machine designed to operate independently or under remote control. It interacts with its surroundings, performs actions, responds to inputs, making it a robotic system. Drones are a specialized class of robots excelling in flying and maneuvering in the sky. This is where the technology meets aeronautical engineering, making it an excellent topic to learn about. There's also a third dimension to consider, known as mechatronics. It involves understanding the electrical, mechanical, and microcontroller aspects of drones. A fascinating toy, a useful machine, a world of knowledge, and a science that many people use to make a living. To comprehend drone dynamics, it is crucial to understand the fundamental movements and terminology that dictate their flight. In this video, we will delve into the basics of aviation movements, introducing the essential concepts step by step. A quadrotor is a robot with 6 degrees of freedom involving rotation along 3 different axes, X, Y, and Z, which define 3 fundamental movements: roll, pitch, and yaw, as well as translation along these axes. Now, what does that mean? The aviation and the engineering industry uses a Cartesian coordinate system as the standard reference frame to describe the movements of any flying machine, such as an aircraft, or other flying machines, such as drones. In this system, x-axis represents the longitudinal axis, which is aligned with the aircraft's length. Y-axis represents the lateral axis, which is aligned with the aircraft's width. Z-axis represents the vertical axis, which is aligned with the aircraft's height. 3 translational movements are translation along the x-axis. This represents movement along the longitudinal axis aligned with the flying machine's length. For a flying machine, moving along the x-axis means flying forward or backward. Translation along the y-axis. This represents movement along the lateral axis, which is aligned with the flying machine's width. For a flying machine, moving along the y-axis means flying sideways, either to the left or to the right. Translation along the z-axis. This refers to vertical movement along the z-axis that allows the flying machine to ascend or descend in relation to its current altitude. 3 rotational movements involve changing the orientation of the flying machine. These include rotation around the x-axis, which is known as roll. This is roll. This movement occurs around the longitudinal axis. This is simply tilting left or right. Rotation around y-axis, which is known as pitch, and this is pitching. Pitching occurs around the lateral axis. When an airplane pitches, its nose points upward or downward. It is tilting forward or backward. Rotation around the z-axis is the last one. This is yaw. During yaw, the flying machine rotates left or right, allowing it to change direction. This is the rotation around the vertical axis, causing the machine to rotate right or left, changing its direction. Let's discuss the term 6 degrees of freedom. In the field of drones, robotics, and engineering, degrees of freedom refer to the number of independent ways a flying machine can move in space. It helps us understand and quantify the complexity of motion that a system is capable of. In the case of a quadcopter, the term 6 degrees of freedom breaks down as follows, and the movements are exactly the same as described before. However, you're watching this quadcopter from front. It also has 3 rotational movements and 3 transitional movements. 3 Rotational movements involve changing the orientation of the drone. These include rotation around the x-axis, roll. This movement occurs along the longitudinal axis. When a quadcopter rolls, one set of wings moves upward while the other moves downward, resulting in a tilt. Rotation around the y-axis is known as pitching, as mentioned before. Pitching occurs around the lateral axis, which is y-axis. When a quadcopter pitches, its nose points upward or downward. It is tilting forward or backward. Rotation around the z-axis, this is yaw. During yaw, the quadcopter's body rotates left or right, allowing it to change the direction. This is a rotation around the vertical axis, causing the quadcopter to rotate left or right, changing its direction. Translational movements are exactly the same again. Translation along the x-axis, this represents movement along the x-axis. It means moving forward or backward for a quadcopter. Translation along the y-axis, for a quadcopter, it means moving left or right. Translation along the z-axis, same as before. This refers to vertical movement that allows the quadcopter to ascend or descend. When someone says a quadcopter has 6 degrees of freedom, they mean that the quadcopter is capable of moving and orienting itself in 6 independent ways. This flexibility enables quadcopters and other multi-rotor drones to navigate through space with a wide range of maneuvers and effectively perform various tasks. These movements wouldn't be possible without the interaction of a number of forces. In future lessons, we'll discuss these forces in details. However, 2 of these forces are thrust and torque. Each spinning propeller creates both thrust and torque. Thrust propels the quadcopter or any multi-rotor through the air and counteracts drag. To maintain a specific altitude, the thrust must balance the force of gravity, which pulls the flying machine downwards. In short, thrust allows the flying machine to maintain a specific altitude. Torque is the twisting force produced by the motors or propellers. It's crucial for rotational movements. To initiate a turn, adjusting the thrust from different propellers creates torque that results in yawing. Torque is what allows the quadcopter to rotate. The quadcopter has 4 motors rotating with a specific angular velocities, and the previously discussed motions are achieved by regulating these angular velocities.